Good afternoon, everyone. So, welcome to lecture 23 of the course on data structure and algorithm. In the last class, we have understood the code implementation of queue, linear queue using array. In today's class, we shall be actually understand. We shall be understanding the code implementation of linear queue using linked list, single linked list. Okay, and just for revision, I'm just mentioning what is the queue data structure. So queue is another scheme of data storage or data organization. Okay, so for example, uh, okay, so suppose this is a value, this is one element in the queue which is added for the first time. Okay, then if you want to add another element into the queue, then let's say it is placed here.
The
Mean,
screen is not visible.
স্যার আপনি দেখা যাচ্ছে না কিছু
Sir, you are not presenting the screen.
Yes, sir.
is it visible now?
Yes, sir. Yes, sir.
Okay. So let's say, okay. So let's say an element is introduced into the data organization scheme which is known as queue. It's a name, the name of an organization. So queue, this sessions is very important. The previous session, today's session is very important because once you complete the code implementation of the applications of linked list and stack which you are doing for the last couple of sessions in the lab, you are actually practicing the code implementation of some applications like polynomial addition, polynomial multiplication. Those are applications of linked list, and postfix evaluation, prefix evaluation, infix to prefix conversion, infix to postfix conversion. This series of problems you are practicing in the laboratory, which are applications of stack. Once this will be completed, then you will start a series of sessions on queue, linear queue, circular queue, maybe priority queue, etc. Both using array or using linked list, you will try with this, right? So that's why these sessions are very important. So queue is a scheme like stack, right? Stack is a scheme how you will store some data into a memory. So there is another scheme which is called queue. This is having its own principle by which you can store some data into some memory. So it's matter about how will you store, organize some data into a memory. How? One of the principle is stack, one of the principle is queue, etc. And what is the scheme of queue? Suppose the first element is added into the memory, stored into memory somewhere. Suppose this one is that first element. Then the second element, and suppose I want to assign some number or index to this element. Let's say 1, which signifies that it has been added in the queue uh, first. Okay, next I want to add another element. Okay, another element, and I want to assign some number 2, which signifies that this is the element inserted second. So this was inserted or added first, this was added second. These numbers are actually signifying the number when it was added into the list or into the queue or into the uh, data structure. Okay, so next, in a similar way, I want to add few more elements into the queue like this, and I want to assign some index number like 1, 2, 3, 4, and then 5. Okay, okay. So this concept will help you to understand priority queue later on. Okay, so these numbers signify when these elements are being added. Okay, now now the principle of queue comes into the picture. What is that? If I want to delete, okay, if I want to delete one element from this thing, or you can say these are connected like this. These are connected like this. Let's say our today's topic is queue using linked list. So in by this using this context, let's say this datas one which are indexed with 1, 2, 3, 4, 5 are connected by some means. You can use array. You have used array. So array is nothing but a contiguous memory location where these memory locations are placed in continuous manner. You don't have to create something or connections which will enable to make them connected to each other, right? But here you have to make them connected because in linked list these memory allocations are not contiguous, they are random somewhere in the memory, so they need to be properly connected. So this should be connected with the next element added to. I can't randomly establish a connection between 1 and 3, or between 1 and 4, or between 1 and 5, because that means something else. So 1 is connected directly with 2, 2 is connected directly with 3, and similarly 3 is directly connected to 4, and 4 is connected to 5. So in this way, if I establish a connection, thereby I can understand it can represent a queue because this is the first element connected, added, then it goes to second element, this element which was added second. And this is one of the principle of queue where 4 can't be added before 3. First, a value or an element with index 1 should be added, then an element with index 2 should be added, then I can't insert a value or add a value element with index 4. I have to add an element with index 3. Okay, you can say also these are like token number or queue number. Whenever you have you right, so whenever you are in your college premise, so you have earlierly deposited some examination fee or admission fee to tuition fees like that, and you have maintained a queue, right? So and that this is similar kind of a queue. So a person who is placed first, she should be finished with its operation, then the job of the second person will be finished, then job of third person should be finished, right? Okay, now after this situation, if I want to add an element, okay, I can't add an element here. Means the question is, what is the position of insertion? Where should I insert a new value? Position. I can't here. I can't place in between 1 and 2, or between 2 and 3, 3 and 4, or 4 and 5. I have to, okay, place this element here, okay, and establish this connection. And for your understanding purpose, you can give a uh, index of insertion, okay, for your better understanding. Though in queue you don't require this kind of index numbers, for just for your understanding purpose. Now I want to delete an element from this queue. How can I delete? Which element should be deleted first? So user don't have any choice. Whoever has been added earliest will be deleted first from the queue. So this has been added earliest as compared to other elements. So this should be deleted first. Then this should be deleted, then this should be deleted, then this should be deleted, then this one, and so on. So this is the scheme of queue, and we have understood while understanding code implementation using queue, right? Using array. Now today we shall do same thing queue using linked list.
So, sir, basically it is following FIFO, first in, first out.
Yeah. So the first in means, you know, this principle is also known as, thank you for helping me. So this principle is also called FIFO principle. Okay. First in, first out. The element added first should be removed first, should be out first. FIFO. And stack is LIFO, lasting faster.
Yes, sir.
Scheme. It is not possible to try other than LIFO in stack, and also not possible to try other than FIFO in case of queue, because the principles are made accordingly. That it should be following FIFO only, and stack should be using following LIFO only. Anyway, so already you got a flavor that how can we implement the queue using linked list. So one by one you can add up. So as you have done linked list, so it will not take much time, because you can see in a this is looking like a now single linked list. So for insertion operation, what you have to do? Insertion at end, and right, because if you want to insert an element here, new element, you are actually adding it at the end of the single linked list, right? And this, and this is pointing towards null. So the insertion or addition of element in queue is nothing but equivalent to the insertion at end in case of single linked list, right? And we know how to do that. Next, I want to delete one element. I can't delete any element randomly from the queue. I must follow the FIFO. So this element should be deleted first. So whoever is the leftmost element in this orientation should be deleted first. So leftmost means that is the first element of this linked list. So deletion is equivalent to, deletion in queue is equivalent to, or removal in queue is equivalent to deleting the delete from first, or deleting the first element. That's it. Okay. So 2 points we have observed, that is addition of new element is equivalent to, you know, uh,
Insertion at end.
SLL, single linked list, and removal one thing I want to mention, that in the last class, while doing queue using single array, so I actually skipped one important test case, very small but important test case. But that algorithm will fail in one test case, which I will show you some later class. Achha, so this is deletion. So you know already that you are in the middle of the data structure class, both in theory and lab. So algorithm you are doing, your program is running good, but still there are a few problems, many problems, maybe some problems. So you have to rethink on your algorithm. Okay, program code you are, whatever you are doing in the lab, that is a practice. Okay, but algorithm should be perfect enough. It should be satisfying all the test cases. It should be as general as possible. So you have to work on that repeatedly. You have to rethink. Okay, that matters most. Anyway, so okay, let's come to the code. Now So there are two newcomers. So if you, for your to help you, I will explain as much as possible. But yes, I may skip some portion. It's your duty to ask your friends after the class without any hesitation which one for some further explanation. Okay. Uh, so let's define the structure of a single node, right? So these are nothing but nodes. These nodes are to be connected. So let's define the structure of a particular element. Struct just a value I want to insert my store inside a node of a queue, right? And for establishing connection, one structure pointer. Start queue node star, let's say link. So this is the syntax. How do we define a structure of a template? This is the name of a template blank such node, right? And it contains two parts. The first part is the data part, where I want to store the information, which is an integer value, and the second part is a pointer, especially structure pointer, which is supposed to point towards the next node. So this arrow is done using the structure pointer. I'm going to declare um, global structure pointer known as first. This is supposed to globally declared structure pointer point towards first node only in the queue. Here I want to initialize the queue with null. Queue initialize to null. Okay. Next, I want to make a menu option. That's it. Okay. Then I'm passing it to switch. For the call a function. Okay. Before that, I have to ask the user to provide the value of the element. That's it. Okay. So here I have to first create a, so suppose I want to add a value element, right? So first I have to create a blank such node which should have two parts, the integer part and the pointer part. And someone must, okay, store this, I mean point towards this newly created node. Let's say temp. Okay. So temp is should be a pointer which should store the address of newly created this node, which is of definition start q node. Start q node. This one. So start q node start temp. Okay. So this is done. So by this single line, this much is done. So let's say address is 700. Now in the integral part, sorry, in the data part, we want to store the value, right? And and another thing you have to do, that is, now what we want, we have taken a pointer which is named as first. So let me change the name of the first pointer from first to front, because these are very popular names which are used in, especially in queue. Those are front and there are rear. The concept of queue tells us that there should be two trackers or two pointers. One pointer should point towards the first element inserted in the list or queue, and another pointer should be pointed towards the last element inserted in the queue. So this is the front globally declared str pointer point towards first node only in the queue. Similarly, we want to introduce now start queue node star rear. Okay, its job is same, but it is pointing towards last element, last node only in the queue. Okay? So this should be repeated. Initially, this should be happening, right? Oh,
স্যার ফ্রন্ট হবে না কোনো?
right. Okay. Thanks. Oh, okay. So this is actually being pointed by front, and this is being pointed by rear. Okay. So that means whenever you want to add this new element node into the list, into the queue, you want to access this node, which is easily possible by using rear pointer, and uh, already temp pointer is being used to point towards this newly created node, right? So let's do this. So how to add? So let's remove this. Okay, and it is having its integral value, data part and linker part. So integral part contains, let's say, 6, and this is null. So this was the scenario before addition, before establishing the connection. Okay, now in green color, what are the connections we have to do? This should be connected towards this. This should be null. That's it. These two. Okay. So temp pointing link equal to null, and then rear pointing link equal to temp. If I do this, then green color connections will be established and this connection will be lost. So in this way, we can add a new element into a non-empty queue. Now,
Acha, sir, one more thing. Also, sir, we have to assign rear to temp, no? So because now the rear will be the last element, which is temp.
ना rear is equal to
yes,
rear pointing link होगा last
yes,
step.
No, after that line,
after that,
after
right.
line 40.
Yes, that's true. Okay. Now, coming to this portion, to whether this algorithm is able to successfully add a new element when the queue is empty.
ना sir.
So initially, front is null. Also, rear is null. Okay, the queue is empty. At this situation, using the code, the start queue node start temp is there. Line number 37 is there. So using 37, a blank node will be created. This is the data part, this is the linker part, and temp is pointing towards this newly created node, right? Then line number 38, temp pointing data equal to value. Okay, so let's say some 10 value is stored in the data part. Then temp pointing link equal to null. So that's also true, it is null. Okay, okay. Then rear pointing link equal to 10. Then rear pointing link. So this is undefined. If a pointer is pointing towards a null, already you have understood earlierly in case of linked list that if a pointer is pointing towards a null, then rear pointing data, rear pointing link, these are undefined syntax. This does not mean anything. So this line is creating a problem. So that's why you have to check here if front equivalent to null. Okay, this is sufficient condition. Okay, or rear equivalent to null. That means queue is empty. Then what will happen in this scenario? Then rear should be pointing towards this. In this situation, rear should be pointing towards this. Okay, that we shall do later. Okay. So in this situation, what are the connections we have to make? That is, front should be connecting to pointing toward this, and rear should be pointing towards this. Okay.
Yes, sir.
So front should be equal to 10, rear should be equal to 10. That's it. Then these connections will be lost. Okay. Else, what should be there in else? At least 40 number line will be there. This is applicable for when non-empty queue, the line number 47. So this is there. Now again we have changed our code again. So let's rethink, redebug the code with the case when queue is non-empty. So let's rethink about this situation, deleting everything. Right. So some way rear is pointing towards this. Okay. Now at this situation, let's try to add another element when there is exactly one element. Let's try to add another element. So this function will be called using temp pointer, another blank node will be created, right? This is the data part, this is the linker part. This newly created node is pointed by temp, right? So now line number 38, temp pointing data equal to some value, let's say 8. Okay, then temp pointing link equal to null. So this is the last node, it is going to be last node. So blank temp pointing link equal to null. That's very fine. But what are the connections you must have now? That is, front is unaltered, no problem. But I want to have this connection. So this is possible. This is the linker part of this node. So this node is accessed by rear. So this linker means rear pointing link. That should be equal to temp. So 40. If front equivalent to null or rear pointing null, no. Coming under else part. And rear pointing link equal to temp. Through that, this red connection is established. And then this connection is lost. Okay, so then what should we do? Now, rear.
So reassign rear to temp,
Right.
because rear should always point toward the last node.
Right. This connection should be lost. This is the new last element, and rear is supposed to always point towards the updated last node. So rear should be equal to 10. And that's it. So now you can again recheck this algorithm again with this case. Suppose in this way the queue is going on getting large, right, gradually, and some time, suppose this is the situation, number of nodes is 6, rear is pointing towards an element with value 6. Okay, so using line number 37 and 38, what is happening? A vacant node is created pointed by temp. A value is already stored over there, let's say 9. Okay? Now line number 39, temp pointing link equal to null. Then line number 40, no, it's false, coming under else. Rear pointing link equal to temp. So rear pointing link, this is rear pointing link, it is equal to temp. That means this. Then rear equal to temp. Rear means this, it is pointing towards this. So this is lost. Okay, so this much is the code. It's very easy and very handy, that addition operation in queue using linked list. Okay, so similarly you can try with, okay, now let's immediately implement the display function so that we can visualize if our code is working fine up to this point. Function We need a traversal pointer. Traversal. Okay. Function prototype. Function call. Okay. এটা কি এলো? Okay. ঠিক আছে? So addition is performing well. Any question up to this? You can ask. Okay. So addition is done. Now it's your home task to do delete operation from queue using linked list. So I can share this code, and using this code here only you can implement the function definition somewhere here for the delete function. ठीक है? Delete operation. So that's
Okay,
all
sir.
for today. I hope all of you have understood well. If you have
Yes,
still
sir.
doubt, you can ask me in the next class. No issue. Stopping my presentation. Thank you.